Topic 7, Part 2. In this topic, we will try to learn how to sketch a graph using first derivative and second derivative. Let's see first. When you have a curve, you want to sketch it, you have a relative minimum and relative maximum. Okay, I show you what is mean that relative minimum and also relative maximum. Okay, suppose that you have a graph look like this one. The relative maximum and relative minimum is this one. This one at this point is called that relative maximum. Meanwhile, for this one, we call that as relative minimum. Similarly, for this case, at this point is a relative maximum, and also for this one is a relative maximum, and this one is relative minimum. Okay, relative maximum and relative minimum. However, between both of the relative maximum, this one is the higher one. What is mean that for this, we also call it as absolute maximum. Okay, absolute maximum, which means that this is the higher one from the other peaks. And of course, for this case, it's called as absolute minimum. Okay, between all the minimum point, relative minimum, and also relative minimum. However, this one is most the minimum one from all of the minimum, so it's called that as absolute minimum. Okay, let's say I pick it as this one as the point. Okay, in all of the peak point, they have x and y point, right? Also x and y point. For this peak, we have x and y point, and of course at this peak we have that x and y point, and similarly for all of the case. Okay, the value of this peak x is known as critical value. Okay, the value of x for the peak, either is its maximum or minimum, the x is called a critical value if it is on the point which is x, y, which is this one, the point of the peak for maximum and minimum, and it is called as critical point. Okay, if only x, is called that critical value, which is the value of x, but if in the form of x and y, is called that as critical point. Okay, and next I want to show you what is the concept of first derivative. Okay, for the first derivative, is also known as a slope, or also known as a gradient, which is the slope of tangent. Okay, if the value of f prime x is greater than 0, means that it is 1, 2, and 3. So this gradient is a positive. You know that it's a linear graph, then this pattern is a positive. And for this one, if the f prime x is less than 0, should be if the value is -1, -2, and less than 0. Okay, it means that the gradient is negative. So if you see the pattern of the linear graph, it's be like this one. Okay, the linear graph pattern will be like this one. However, if the f prime x is equal to 0, it means that it is horizontal. When will that happen? When it will be the horizontal, it occur when it is at always on the peak. Okay, when they are at the peak, the graph of the tangent, the gradient will become horizontal. But we don't know either that is on the maximum or it also at the peak of the minimum. Okay, for second derivative, the similar concept is also show where if they are second derivative, if they are greater than 0, which is 1, 2, and 3, and the others is positive, it is concave up. And of course, concave up, which is look a smile. But if they are less than 0, which is -1, -2, and others, and that will be a concave down. Okay, it will be concave down. However, if the f prime x double prime x, which is equal to 0 when you second derivative, it become equal to 0, it maybe it's an inflection point. Maybe it is inflection point. Okay. For this case, let's say they have a point at here, and you will have a slope of tangent. This is a tangent, slope of tangent. Okay, at this point, and this show that the gradient is negative, so it is less than 0. Similarly for this case, okay, the tangent for the graph is less than 0. Okay, which is the m is negative, the gradient is negative. And if they are look like this one at this point, let's say at this point, what is the slope of tangent for this case? Okay, I put the linear graph going through for this point, and you can see that the pattern is like this one. It means that if you differentiate at this time, it will be greater than 0, so the gradient is actually positive. Okay, what is mean here, the first derivative, please take note that first derivative is to make sure that either the slope is a gradient, the slope or the gradient is positive or negative. That is the pattern. And of course, if you see for this case, when they are horizontal, means that for this case it is horizontal, it always be at the peak. Okay, horizontal. Okay, so if you want to find at the peak, you can do a first derivative and then you assume that as equal to 0. So when that first derivative is equal to 0, so it will be that at the peak. Okay, however, there are some cases when you differentiate f prime x, you first differentiate, it will be undefined. There are three cases. Maybe when you differentiate, it can be undefined when they are like this one. Okay, for this one, you have at the point this one, how you want to determine the gradient. Okay, how you want to sketch the tangent for this point, you cannot write, so that's why it may be undefined. Okay, if the graph is look like this one, so at that point when you differentiate, it will be undefined. Similarly for this case, if you have this one at this point, at the inflection point, so the gradient is perpendicular. Okay, when they are perpendicular, so you doesn't have a gradient. Okay, you don't know the value, either it's 0 or positive or negative, because it is perpendicular. Okay, and the third part, if you want to find the point of A, you want to find the tangent, it have 2 times of tangent, but you don't know which one is it. Okay, for this case it is f undefined for the first derivative because they are not connected. Okay, if they are not connected, at that point the first derivative will become undefined. So if you find the question that you differentiate and then it become undefined, okay, it will be on this condition: the first condition, the second condition, and the third condition, either one of them, when f prime x is undefined. Okay, now we want to learn how to sketch the graph for the curve graph. The first step, you need to differentiate first f prime x, and then you assume that f prime x is equal to 0 because you want to find the critical point. Okay, and then after you find the critical point, you do a second derivative, second differentiate. You want to identify either that critical point is maximum or minimum point. Okay, and after that you identify that interval that you get from the step 1, okay. And step 4 is you want to create a sign of table. Okay, and step 5, you find the inflection point, and then step 6, you sketch a graph. Okay, there are 6 steps. First, find the f prime. Second, identify the maximum and minimum point, and then identify the interval from step 1. And 4, correct the sign of table. And 5, find the inflection point. And 6, sketch the graph. Okay, let's say for the first example, first you have the equation for this point. Okay, you have the equation which is y equal to 8x minus 2 over 3x power of 3. Okay, you want to sketch the graph. Okay, first step, differentiate this one, which is 18x become 18, 2 over 3 x power of 3 will become 2x power of 2. Okay, okay, let's see how you show this one. 2 over 3, okay, when you differentiate this one, 3 move to the front, 2 over 3, 3x, of course 3 minus 1. Okay, you can eliminate this one, it become 2x power of 2. Okay, that's how you get for 2x power of 2. And then I factorize it, make sure 2 at outside, which is 9 minus x, 2. Or you can use calculator. Okay, because if you use calculator, you will get that directly, which is x equal to negative 3 and x equal to 3. Okay, you can do one step by step, or you can use from this one. From this one, you find the using calculator, and you will get that x equal to negative 3, and the other is x is equal to 3. Okay, the first step, you get 2 points, which is critical value, negative 3 and 3. Okay, okay, you get this point, x equal to negative 3 and x equal to 3. When you define that, you assume that dy per dx is equal to 0. Okay, then you will get this value actually. Okay, after you differentiate, you assume that it's become to 0, and then you will get that x equal to negative 3 and x equal to 3. Next, I do a second derivative, which is from this one is first derivative. I differentiate it again. It will become 0 for this one, and this one will become negative 4, negative 2. 2 move to the front, become 2, x power 2 minus 1, and at the end it becomes negative 4x. Okay, this is the second derivative. And I want to identify either it is maximum or minimum point, which is we have negative 3 and 3. So we just substitute first. For this one, negative 4x. Okay, first we substitute with negative 3, substitute with negative 3, and you get that it's 12 greater than 0, so it is a minimum point. And then I substitute 3, and then negative 4 multiplied with 3, you get that negative 12 is less than 0, so it is maximum point. Okay, so if you have a graph at negative 3, it will be like this one, and for that it is 3, it will be like this one, minimum, maximum, sorry. For this one, it's a minimum, so if negative 3, it will be like this one. If they are at here, which is 3, it will become like this one. Okay. Next, since you already get that this is negative 3 and 3, I do a line, and then I put that negative 3 and 3, and then you can see that for this one is x less than negative 3, and this one between negative 3 and 3 is negative 3, x 3, and of course at the above of 3 is x greater than 3. This is how you want to identify the interval, because I want to find the value what is actually from the interval. Okay, step 4, you want to create the table of sign. Okay, I put that 3 and negative 3 and 3, and then make sure you have the table from the front and the back, and also for 3 the front and at the back. Okay, so if you create the table, you have to point negative 3 and 3. Make sure you have one column for at the front and one column at the back, and for the 3, one column at the front and one column at the back. Okay, the reason is because I want to make sure either between from negative 3 and 3 they doesn't have any inflection point or they have an inflection point. Okay, to create the sign of table, you have to point, make sure first column at the front, second column at the back, first column at the front, and second column at the back. Clear? Okay. Next, since you know that at the front is less than negative 3, so let's say I put that it's negative 4. Okay, I just take it at this column as value is negative 4, and between negative 3 until 3 you have 2 columns. So let's say the nearest one is negative 2, and for the nearest one is this one, and let's this 2. Okay, and above of 3 for this column the value should be 4. Let's say I take this one as a 4. You can take any value you want based on the interval. Okay, what in here I want to focus on this step. Okay, you can just ignore this one. Okay, for the first derivative column, okay, I substitute negative 4 into this one. Okay, you will get the value substitute, which is 18 minus 2 negative 4 power of 2, and then you will get that the value is negative. Okay, I just want to know the sign, not the value. Either the sign is negative, the value is negative, or the value is positive. Okay, when I substitute it become negative, And of course, I do a second time negative 2, substitute into this one, 18 minus 2, negative 2 power of 2, and I will get that positive value, so it become positive. Okay, negative 2, 2 power of 2, you will get that the value is 10 actually. For this case, you get 10. So since it is positive, 10 is positive, so I put that is a positive. Do the same thing for 2 and 4. Okay, for the first derivative, which you get that negative, positive, positive, negative. And next, for the second derivative, you get that negative 4x, right? This one, you differentiate, you get that negative 4x. So you need just to substitute the value for negative 4 inside of this one. Negative 4, substitute negative 4, you will get that it's become 16. So 16 is positive. So its value is positive. Similarly, do for the case of negative 2, 2 and 4. When you substitute, it will become positive, negative, and negative. Okay. Next, after you do a table of sign, okay, I remove this one first. Okay. Let's see for this case. You have a negative for first derivative. First derivative means a slope, right? The slope tangent. So negative is look like this one. And then when there are 3, it is 0. The first derivative is 0. So it's become like this one, perpendicular, horizontal. So then it's a positive. So you go then again, it is positive. And after that, it's positive again. You increase again, positive. And then it is 0 at the 3. So it's horizontal. And then it's negative, it decrease, which is negative. Okay, this is how you want to find to sketch a graph using first derivative. Okay, when negative, like this one, 0 is this one, horizontal, positive, this one, positive, increase again, horizontal, and then decrease. Okay, however, please look at the second derivative. In second derivative, you see this one, it is concave downward, and then you concave downward, okay, and then it is negative, so you concave upward, and then you concave up, concave upward, and then concave downward, and concave downward. Okay, for this case, you can see that it is positive and negative, which is from concave upward and concave downward. You can see that there are changes up to down. So it may be it have an inflection point. When for the second derivative, if there are different sign changes, which is positive to negative or negative to positive, it means that it have an inflection point. So how you want to find the inflection point? What I do from the second derivative, which is we know that negative 4x, I assume that it's equal to 0. Okay, assume andaikan equal to 0. So it's look like this one, which is negative 4x is equal to 0. I move negative 4 is x equal to 0 divided by negative 4. Of course, x equal to 0. Okay, since you know that x equal to 0, okay, I just substitute for this case. If you do a interval which is 0 at this point, okay, for this one negative infinity 0, and this one 0 and infinity. So let's say this one is negative 1, this one is 1. Okay, if you substitute, which is fx equal to negative 4x, you substitute negative 1 into this one, you will get that value is positive, and if you substitute the 1 into this one, it will become negative. So you can see that it is upward and concave downward. So because it shows the sign of concavity is different, okay, from the right and the left, we say that the point of inflection point occur at the point of x equal to 0. Okay. Now you already have 3 points, which is x equal to negative 3 before this, and also 3, and then you added one thing again is 0. So I want to find the I want to find the point. So what I will do, you have 3, negative 3, and 0. I substitute into this one the original formula, the original equation. When I substitute 3, I get that it is 36. Okay. When I substitute negative 3, I get that it is negative 3, negative 3, 6. Okay, this is the point. When I substitute 0, I get that it is 0 and 0. Okay. The inflection point occur at 0 and 0. Okay. I just substitute 3 into this one and this one. I get that 36. I substitute negative 3 into this one and this one. It becomes negative 36. And when I find the point for the x equal to 0, I put 0 here, I put 0 here, it will become 0. So I get 0, 0. So you have 3 points. 3, 36, negative 3, negative 36, and the other is 0 and 0. So how I want to sketch the graph? First, I put that the point is 1, and point is 1, and the point is this one. Okay? First, how you want to sketch a graph? You just put the point which is the maximum, minimum, and inflection point. Okay? Next, you know that 336 at this point, it is concave downward. Okay? It's like, look like this one. And also we know that it is maximum point. Okay? This one is a minimum point. Okay? This one is the inflection point. Okay? You just connect all of this information, which is minimum, going to the inflection point, going through of this one, and then it going to the point at the maximum, and then it's going down. Okay? Again, I show you. First, sketch the point, put this point first on the paper graph, and then you know that this point is a maximum, a minimum, and this one is a maximum. Okay, just put that maximum and minimum, and of course you do this one as an inflection point that connect between the maximum and minimum, and then you just connect all of this point, and you will get that look like this one. Okay. Okay, how to sketch the graph is just connect all the line that you find from the first derivative and the inflection point. Okay, let's see for example 2. For the case of example 2, let's say for this case, fx equal to this one, you can change that into x power of 1 over 3. If you want to differentiate fx, it becomes f prime x. So of course 1 over 3 move to the front, this becomes 1 over 3x 1 over 3 minus 1, and you get that 1 over 3x negative 2 over 3. Okay, this is how you get this one. Since it's a negative, so you can move it downward, it's become like, look like this one. Okay, and then for step 1, you assume that it is equal to 0. However, when you assume that it is equal to 0, it can be not defined or undefined. Okay. The reason is because if you assume that this one is equal to 0, if you move this one to the left side, it will become 0. So you doesn't get the value of x. Okay. So what I assume, there are three conditions. Maybe it look like this one, the graph. Maybe it is look like this one, which is it is on inflection point, or at the peak of this one, or the graph is not connected. Okay. So for this case, I assume that it is have an inflection point. For the first step, you first differentiate and find the value of x, but you doesn't have the value of x. Okay. Because you cannot move the x to the left side. Okay. When for this case I say that x is equal to 0, when x equal to 0, for this one is 0, 1 over 0 is undefined. Okay. If you find that you put that 1 over 3 of power, this is negative 1 or 2, it still get the value, so it's defined, but it become undefined when it is equal to 0. For this case, we can say that it's undefined when x equal to 0. For this case, we say that when x equal to 0, it become undefined because 1 over 0 is undefined. Okay. And then I substitute, and then I do a second step. The second step is second derivative. Okay. dy per dx, I change back 1 over 3 x power of negative 2 over 3, and then second derivative okay, 1 over 3 negative 2 over 3. I move this one to the front, and x equal to negative 2 over 3 minus 1. You can see that it can directly multiply, which is negative 2 over 9 x power of negative 5 over 3. Okay, because they are negative, so I can move down, so it look like this 1. Okay. And of course, when I substitute x equal to 0, which we know that x is undefined, x equal to 0 inside of this one, when we also get that is undefined. So this squared y dx squared is not undefined, since we cannot know that either it is maximum or minimum. Okay. I want to show you that when this squared y per dx squared, we assume that is equal to 0, we substitute for x equal to 0, we cannot find that it is maximum or minimum. For the third step, we find the interval, and of course, it's less than 0, it can be negative 1 to negative 2, negative 3. And for this case, it can be either 1, 2, 3. Okay. For that sign of table, this is the formula for the f prime x. This is for double prime x. Okay. Which is, let's say, is negative 1 and 1. When I substitute negative 1 inside this one, we get a positive value, which is you get that 1 over 3, the value actually. Okay, you put that negative 1 inside this, you get that 1 over 3, so it is positive. Similarly, if you put this one, it become 1 over 3 also, and it is positive. Okay. On the next one, for the second derivative, you put negative 1 inside of this one, you get that it's become positive 2 over 9. Okay. And if you substitute this one into one of this one, it become negative 2 over 9. Just substitute 1 into this. When you calculate it, become negative 2 over 9. Okay. This one is concave upward. This one is concave downward. So you can see that this one, the sign is changes from positive to negative. So for this case, I assume that maybe it have an inflection point, okay, at x is equal to 0. If inflection point maybe of inflection point, but because we have shown that from this table, when you substitute the value from the left side and the right side, you can see that difference change. So you already proved that x equal to 0 is inflection point, and I just substitute x equal to 0 into the formula of fx. Okay, the first formula fx. Okay, you substitute, you will get that it is equal to 0. Okay, so you get that the point of inflection point is 0, 0. So if you want to sketch a graph, you doesn't have maximum. For this case, the equation is you doesn't have a maximum, you doesn't have minimum. Okay, you doesn't have critical point. Either it's maximum or minimum, we doesn't have that. We only have that the point of inflection point. So this is what happened. You put this point 0, 0 is inflection point, concave upward, a concave downward, and this concave upward. Okay, it is how the inflection point. And make sure, because it is undefined, so this one the gradient is perpendicular. Okay, lurus. So this how you get this one. Okay, again for the third example, suppose that you have this equation, and then you first derivative. Step 1 is first derivative. Differentiate 6x4 power of 4, it become like this one, 24 x power of 3. Differentiate x power of 3 become like this one. Differentiate 1, it become 0. Okay, and then you assume that the first derivative is equal to 0. Okay, you want to find the gradient when it is perpendicular, it is horizontal. So just use calculator. 24x power of 3 minus 24x squared equal to 0. Okay, when you assume that it's equal to 0, use calculator and you get that it's x equal to 0 and x equal to 1. You get these 2 points. Okay, if you don't want to use calculator, the first one, when will be this one will become 0? This one will become 0 when this one is become 0. Okay, and the other is when all of inside of this one becomes 0, which is x minus 1 becomes 0. Okay, x equal to, move this one to the right side, become 1. Okay, so the condition for this one to become 0, like look like this one, is when this one is become 0, or the other inside of the bracket becomes 0, and you get that x equal to 1. So you can get that it is x equal to 0 and x equal to 1. You have get 2 points. You already get 2 points. Then I want to identify either this one, 0 and 1 is maximum or minimum point. So I do a second derivative. Step 2, differentiate this one, 24, 3, x power 3 minus 1. Differentiate this one, 24, 2, move 2 to the front, x power 2 minus 1. And I get that it's become 72 x power of 2 minus 48x. Okay, and then I substitute the value of x equal to 0, and you get that 0. So it may be inflection point. May be inflection point because we need to prove using concavity. And the second one, we use 1, substitute 1, you get the 24, which is greater than 0, so it is minimum point. Okay. Step first, you differentiate, find the value of x. Step 2, you differentiate again for second derivative and substitute the value of x. You find that either is maximum or minimum. Okay. For this case, when you substitute 0, you get 0. It's not show that either is greater than 0 or less than 0, so it may be inflection point. So step 3, you want the interval, which is you put that 0 and 1, and then you know that x is less than 0 for this case, this region. And for this region, at the middle is until from 0 until 1. And for the other region, it means that x is greater than 1. The value is. So the fourth step is sign of the table. First, I put that 0 and 1. Okay. I choose the nearest one. Let's say this one is negative 1. Okay. From interval, which is, I put that this column. Okay. First, how to sketch the column for this graph. Make sure you have one column at the front, one column at the back, one column at the front, and one column at the back. Okay. And then for this one, I put that as negative 1, less than 0. And this one, I put that is 2. The value will become 2. For this column is 2. But the interval from 0 until 1, I know that at the middle maybe is 0.5. So I just take the nearest one is 0. Let's say 0.2. And this one is 0.9. Okay, the nearest one. Maybe it can 0.1 also can be like this one. You can also choose as 0.1 because this one is depend on you how you want to choose the value. Okay. So I just put the value of negative 1 similarly like before. Negative 1 intersect this one. You get the sign is negative. And similar for this case, negative and negative and positive. When you substitute this one for negative 1 and negative 1, you get the value is positive, negative, positive, and positive. Okay. Next, I use the second derivative. I want to show you that it is concave upward for positive, concave downward for negative, upward for positive, and upward again for the positive. But look at here, you have that two circle in here. I do at two circle because from positive to negative, they have the changes of sign. Okay, sign yang berubah, positive to negative, and next is negative to positive. So it maybe have two inflection point. Okay. For the zero, we already know that the point at the 0, since we show that when we substitute 0 inside this one, we already assume that it is inflection point, but we need to prove using sign of table. When I prove that, I already proved that they have a changes of sign. Okay, since they have a changes of sign, so it is an inflection point at 0. But for this case, what is the point actually? Okay, to find the point for the second inflection point, because x equal to 0 is inflection point, it has one more inflection point between 0 until 1. From 0 until 1, we have one more inflection point. We need to find the second inflection point by differentiate again. Okay, from the second derivative you differentiate, you assume that it's equal to 0. Assume it is equal to 0. And of course, 7 to power of 2 minus 48x is equal to 0. Okay. Okay, you can use calculator and you will get that x equal to 0 and also x equal to 2/3. Okay, if you don't want to use calculator, you can factorize like look like this one. When it will become 0, when will be at this side will become 0, it will be when x equal to 0. Okay, when this one becomes 0, overall will become 0, and the other inside of bracket becomes 0. If the inside of bracket becomes 0, overall will become 0. Okay, move this 2, move 3. Okay, you get that x equal to 0 and x equal to 2 over 3. So I already get this point, 2 point, but maybe it be inflection point. How I want to show that it is an inflection point, I need to use a table of sign. Okay, I just want to check on this point 2 over 3, because for 0 we already proved that for this case. Okay, because this one we doesn't prove yet 2 over 3, so I just take it, the nearest one is 2 over 3. If I do interval 2 over 3, okay, the nearest one is 1 over 3, and for this one the nearest is 1. So I put that this one is 1 over 3, and then this is 1. I substitute into this one, 72x squared minus 48x. Okay, for this case I get that it is negative, and the other I get positive, which is concave downward and concave upward. It shows that the sign of concavity is different from right to the left, so x 2 over 3 is inflection point. Okay, next I find how I want to sketch the graph, so I need to find the point. So from x 0, 1 and 2 over 3, I substitute into this one. Okay, first I substitute 0, 0, it become 1, and then 1, 1, it become negative 1, and then 2 over 3, 2 over 3 inside of this one, it becomes 0. So, sorry, 2 over 3 and 2 over 3, it will become negative 5 over 27. Okay, so you will get that 3 point. First, this is inflection point, this is minimum point, this is inflection point. So I want to sketch the graph. Okay, I put that this one first, I put this one and also this one. Okay, this one is inflection point. Okay, this one is inflection point, this one is the minimum point. Okay, which is 1, negative 1 is minimum point, so I put that this 3 point. Okay, you know that it's concave downward, and then concave upward, and then concave upward, and concave upward. Okay, after I put that this 3 point, a concave upward, concave downward, and then it become concave upward and concave upward again. Okay, because you know that this is the point of inflection point. For minimum, it's become like this one. You just connect concave downward, a concave upward, and then it's concave upward. Okay, and then you get this point is minimum point, you just connect of this one, and then concave upward. Okay,